Okay, this video tutorial looks at the mathematical strand of networks, and more specifically, we're going to focus our understanding on the number of paths within a network. So, how many paths in a network? So remember that a path within a network is when you start at one node and finish at another. Okay, so that's really important. We're not looking at circuits, we're looking at paths. So some networks will have very large number of paths, obviously dependent on the amount of edges and the amount of nodes that they have. So basically, to determine the number of paths, we can either just trace and count, and that's great, or we can follow what's called an algorithm. Now, an algorithm is basically a series of steps to find the total number of paths within a network. And we're going to go through an example in a minute about how we can do that. So let's have a look at an example here. We have a network alongside, and we want to find out the number of paths from A to B. So we're starting at A, we're finishing at B. Now, like I said earlier, briefly, we can sort of trace them all, which is great, or we can do something called an algorithm. Now, basically from A, so from our starting point, there are two possible nodes that we can go to. And each way only has one path. Okay, so we can either go up here or we can go to here. There are our one options. Yeah, either way. So that gives us one option going up, one option going to the side. So we put a 1 at those nodes because there's only one way we can get to those nodes. All right, from A. We then look at the next step in our journey, so in the path. And at each node, we add the numbers from the previous nodes which lead to that. So for example, our middle number is going to be 2 because we've added the 1 and the 1, because we can either go up across or across up. All right, and that'll give us 2. Okay, and then we keep adding on from there. So for example, this becomes a 3 because we've added the 1 and the 2 to make it a 3. This also becomes a 3 because we've added the 1 and the 2 to make it 3. And then our final answer is going to be 6 because we have a 3 and a 3 and we've added together to make 6. So there are 6 possible paths to get to B. It's important to note, okay, so down the bottom here, if we need to avoid a given node, we immediately place a 0 at that node. That means you don't go through it. But if we have to pass through a particular node, we place a 0 at the other nodes, okay, that do not allow passage through. All right, so we're going to go through an example of that. Okay, so let's have a look at this example question. It says Alvin wishes to visit Barbara. So I'm reading up here. Alvin wishes to visit Barbara across town. Alvin's other friend Sally lives at the intersection of S. This is based on our diagram here. Find how many different paths from A to B are, if possible, if there are no restrictions. So let's look at no restrictions at the moment. So basically, if we are at A, again, we can go either way. And we're going to put a 1, all right, when we go either way. And when we add our nodes together, obviously it's going to give us a 2 here, but we're still going to have a 1 on the side. So all of the ones on the side, or all of the nodes on the side are given a 1. But as we add across, all right, we get a 3. And we add across, we get a 4. We add across, we get a 3. We add across, we get a 6. All right. We add across, we get a 4. We add across, we get a 5. We add across, we get a 10. We add across, we get a 10. This is going to give us 20. This is going to give us 15, which means we have a total of 35. All right. So remember that we're adding our options to get to each node every time. The question part B says Alvin must visit Sally along the way. Now, if they must visit Sally, then we put a 0 on all of the nodes that we're not going to use. All right, so we're not going to use this node up here because there's no way that gets to Sally without backtracking. We're not putting, we're going to put a 0 here, and here, and here, and here, and here, because if we go to those nodes, the shortest, quickest way is to get to Barbara, and we need to visit Sally. All right. So now that we've done that, we're still going to put our numbers, all right, on the nodes, and we're going to add them together. 3, 3 gives us 6, which is great. Now the next nodes are still 6 because we have to go through Sally to get everywhere. All right. We add them together, get a 12. This remains a 6 here because we haven't, there's no other option. All right. Which means we end up with 18 as our number of paths. All right. Now, in C, we can do the exact same thing if we want to. And we can, I'll use a different color here. Let's use purple. All right, we can go 1, 1, 1, 1, 1, perfect. All right, and we can do all our numbers. Remember that we put 0 on Sally because we don't want to visit Sally. No offense to Sally. All right, and then we can add it all together again, and we can get 2, and we can get 3, and we can keep going and whatever we want to do. But there's an even better way we can do this. If there's 35 possible outcomes, okay, with no restrictions, all right, and we then say we have to visit Sally, and there's 18 possible when we have to visit Sally. Rather than adding up everything like we've done over here, we can just take away and work out, well, there has to be 7 possible outcomes if we don't no visit Sally, right? And therefore, we can get the 17, all right, because there's only 2 options. We either visit her or we don't, all right? And if we visit her, there's 18 possibilities. If we don't visit her, that must be all the other options, which gives us 17. So you can do your adding if you want to, or you can simply subtract from the total possible outcomes. Okay, so here are some practice questions I would like you to have a go at. Basically, you're just trying to find the total number of paths from A to B in each scenario. Please feel free to pause the video, and once you think you've got the correct answer, continue the video and we'll see how you went. Okay, so let's see in our first example. All right, we can put a 1 and a 1 here because there's only one way to get to those nodes. And if we add those two, so there's a 1 and a 1, if we add them, we get 2, so we can put a 2 in the middle. But up the top corner, we're still only getting 1, and we're still only getting 1 here. If we add these, we get a 3, and if we add these ones, we get a 3. We add these, we get a 6. So therefore, there are 6 paths in our first example. In our next example, we can put a 1 here, and we can put a 1 there, which gives us a 2, which is great. We stay with the 1 because there's only one way to go. This gives us a 3. We have a 1 over here because that's only one way to go along the top, and that gives us a 4 here. Since we have a 3 already, this must be a 3 as well. All right, and we can add those to get 7. All right, so I've added these to get the 2, I've added these to get the 3, I've added these to get the 4, and then I've added the 3 and the 4 to get the 7. So we have 7 paths. In our next example, we have a 1 and a 1, which gives us a 2 when I add them together. I have a 1 here, which gives us a 3 when I add them together. I have a 1 here, which gives us a 4 when I add them together. On the outside again, I've got a 1 and a 2, which gives me a 3, which is great, and I have a 1 in my corner, which gives me a 4. Now if I add the 3 and the 3, I get 6. If I add the 4 and the 6, I get 10, and again if I add the 4 and the 6, I get 10, and if I add the 10 and the 10, I get 20. So this one has 20 paths. In our last example, we have a 1 and a 1. That gives us a 2, which is great. I have a 1, so I've added these 2 to get the 2. I've added those to get my 3. I've added those to get my 4. Fantastic. All right. If we're going to go along this way, we still have a 2 because there's no other option. All right. So I add those 2 and I get a 5, which is great. This still gives me a 2 here. So I add these 2 and I get a 7. Now if I'm going to go this way, this still becomes a 5. All right? And a 5 and a 4 gives me 9, and a 9 and a 7 gives me 16. So therefore, I have 16 paths.